Hey everyone, welcome back to the channel. Today we are starting trigonometry and the idea is actually very simple. So what is trigonometry? Trigonometry is all about using how the angles of the right angle triangle are connected to the length of its sides. And if you know any one angle and any one side of the right angle triangle, you can find everything else, means the missing sides, the other missing sides and the other missing angles. And that is the power of trigonometry. So let's take a right angle triangle. If this is a right angle triangle, of course, one of the angle is 90°. I will name the triangle as PQR. And if one angle is 90, the other two angles will be the acute angles. I will take one of the acute angle and I will call it as a theta. Now, all the three sides of the triangle gets its name based on where these sides are relative to this angle theta. First of all, this slanting side, which is directly opposite to 90° angle, is called as the hypotenuse. And always remember that hypotenuse is always the longest side of the right triangle. The side, this PQ side, which is across from theta or which is actually the exactly opposite to this theta, is called as the opposite side. And the side which is touching this angle theta, this QR side which is touching angle theta, is called as the adjacent side. Okay, once you know all these three names, that which one is the opposite side, which is the adjacent one, and which is the long hypotenuse, all the trigonometric ratios make perfect sense. Now, what are the three main primary trigonometric ratios? Trigonometric ratios are the base of the trigonometry. Everything is based on these three main primary trigonometric ratios. So I will again name the triangle as PQR, and where my angle Q is 90°, and I will pick any one of the acute angle and I will name it as theta. And this is of course the hypotenuse. The side opposite to theta is of course opposite side, and the side touching theta is called as the adjacent side. Now, the three primary main trigonometric ratios with respect to this angle theta is, the first one is sine of theta, and in short it is written as like this. Okay, we just take out this e, sine theta. This sine theta is the ratio of the opposite side to the hypotenuse. All right. My next trigonometric ratio is cosine of the angle theta. In short, it is written as cos theta, and cos theta is the ratio of the adjacent side to the hypotenuse. And my third main primary trigonometric ratio is tangent of theta. In short, we say and write it as tan theta. It is the ratio of the opposite side to the adjacent side. Once these three ratios are there, and then you can find any missing angle, any missing side, or whatever you want to solve with respect to this right angle triangle. So sine theta is opposite side over hypotenuse, cos theta compares adjacent side to hypotenuse, and tan theta compares opposite side to adjacent side. A really easy way to remember all these three ratios is the phrase so ka chua. So ka chua. Okay, why? Because sine is the ratio of opposite side to hypotenuse. Look here, opposite side to hypotenuse. I'll change my pen to see it. So sine is the ratio of opposite to hypotenuse. This cos is the ratio of adjacent to hypotenuse. So look here, cos is the ratio of adjacent to hypotenuse. And in the last, this tan is the ratio of opposite to adjacent side. So tan is the ratio of opposite to adjacent side. So sine is the ratio of opposite to hypotenuse, cos adjacent to hypotenuse, and tan opposite to adjacent side. So katua, you remember this phrase and you will never forget any of the trigonometric ratios. These were my three main primary ratios. My other three trigonometric ratios are actually the reciprocal of those three, the three ratios which we just discussed in the previous slide. Okay, so let's again name it as PQR. Of course, angle Q is 90 and my angle R is theta. This is hypotenuse, this is opposite side, and this is the adjacent side. My next three trigonometric ratios are cosecant theta, Then I have secant theta. And my last one is cotangent theta. Cosecant theta, in short, is written as cosec theta. Secant theta is, in short, written as sec theta. And cotangent theta is written as cot theta. Now, cosecant theta is actually the reciprocal of sine theta. Okay. Now, what was sine theta? Sine theta was opposite over hypotenuse. So cosecant theta, because it is a reciprocal of sine, it will be the ratio of hypotenuse to opposite side. And no need to remember this. Like if you know that cosec theta is the reciprocal of sine, you can just take the reciprocal of opposite over hypotenuse as hypotenuse over opposite, and you are done. Secant theta is the reciprocal of cos theta. What was cos theta? Cos theta was adjacent over hypotenuse. So secant theta is actually the reciprocal of this. So you can say this is the ratio of hypotenuse over adjacent side. The last cot theta is the reciprocal of tan theta. Tan theta was opposite over adjacent. So this cot theta, I will write it over here. Cot theta is the ratio of adjacent to opposite side. There is nothing to memorize these three ratios, because once you know the primary ratios, sine, cos, tan, we know that these are the actually reciprocal of sine, cos, tan. So these ratios will follow automatically. Just flip the fraction and you will get these three reciprocal ratios. So that's the foundation of the trigonometry. In the next videos, I will use these ratios to find the missing lengths and missing angles, and to solve and to find other elements of the right angle triangle. All right. Thanks for watching. See you in the next one. Please hit like button and subscribe to my channel. Bye bye.